Hello, hello, hello. Thank you for joining me for assignment 56, Graphing Rationals number 2. Um, and in this unit, I want to talk about slant asymptotes and holes. That's right, our graphs can have holes in them. But before we do, just to warm you up, will you graph for me y equals 3x squared minus 12 over 5 minus x squared? Fabulous. Give it a go. Let's see what you remember from the last video. All right, so if I set the top equal to 0, I get 3x squared equals 12, or x squared equals 4, or x equals plus and minus 2. Don't forget to take that square root. Okay, so I've got two x-intercepts. These are my x-intercepts. My y-intercept, I plug a 0 in for the x's. I get negative 12 over positive 5. Y-intercept is negative 12 fifths. I set the bottom equal to 0 to find vertical asymptotes. My vertical asymptotes are plus and minus root 5, right? Because I'm going to be doing 5 minus x squared equals 0. And then I add x squared to both sides. 5 equals x squared. Don't forget, when you take the square root of both sides, you need that plus and minus, okay? And then what about degree? Well, because the degree here is 2 and the degree here is 2, we're just looking at the ratio of leading coefficients. I have a 3 on top, I have a negative 1 on the bottom. So my horizontal asymptote is negative 3. So let's graph what we know. We've got two vertical asymptotes, one over here at root 5, one over here at negative root 5. I have x-intercepts, remember, of plus and minus 2. Well, 2 is also the square root of 4. The square root of 4 is less than the square root of 5, so 2, but also at negative 2. This is a little bigger than negative 2 because it's the square root of 5, not the square root of 4. So negative 2 here. I have a y-intercept at negative 12 fifths. Hey, look. We get our up-pointing parabola. We actually do have enough x-intercepts for this shape. We have to pass through that. And yes, for the first time maybe all year, our vertex is actually on the y-axis. All right, so what are we done? No, we need something over here and something over here. Now, to the right of the square root of 5 is the square root of 9, which is 3, and negative 3. Those are going to be my test points to see if I'm up here or down here. All right, so if I plug in a 3, 9 times 3 is 18. 18 minus 12 is 6. And a 3 here, oh, that's going to be 9. 5 minus 9 is negative 4. So I get 3 negative 6/4 or negative 3/2. So now my graph has to be doing this. No x-intercepts, so I'm not crossing. I'm just approaching my asymptotes. Now here, do you think I'm going to be up here and do this one, because that's that kind of diagonal thing? Or am I going to do here and sort of be a reflection of that? Yeah, I don't know until I test. I mean, I guess I could check to see if this was an even function or not, because that would have y-axis symmetry. But yeah, no, I'm not going to do that. Instead, I'm just going to plug in a negative 3. And since I'm squaring these numbers, I get the same y value that I had before. And so my graph looks like, whoa, Kukla, hold that thought. Where's your horizontal asymptote? Okay, so this is negative 12 fifths. That's negative 2 and 2 fifths. But our horizontal asymptote is at negative 3. So my horizontal asymptote is down here. Y equals negative 3. Well, does that change my shape? What happened when I plugged x equals x equals 3 in here. I have 9 times 3 are 18, minus 12 is 6, and I have 5 minus 9 for negative 4, negative 3 halves. I suddenly feel very uncomfortable because this is supposed to be at negative 3. And negative 6/4 or negative 3 halves. That's negative 1.5. That's here. But I don't have an x-intercept. So I can't do that. Well, are these correct? Square root of 5 and negative root 5? Yeah, those are correct. And I added 12 and divided by 3 to get 4. And I took the square root and I have plus and minus 2 for x-intercepts. And the square root of 4 is definitely smaller than the square root of 5. Huh. And this is a 3, and this is a minus 1. And so I do have negative 3 here. Huh. And the y-intercept. Well, there's that negative 12. There's that positive 5. 5 goes into 12, 2 with 2 left over, so that's above this. Huh. I'm going to try that test point again. This is 5, square root of 5. So square root of 9 is bigger than the square root of 5. Square root of 9 is 3. 3 times 3 is 9. 9 times 3 is 27. There's the mistake. 27 minus 12 is 15. And on the bottom, when I plug in a 3, I still have my negative 4. Oh, that's much better. Thanks. You know, it is okay to think about things like that to cut down on your mistakes. So this is 3, negative 15/4. That's going to be almost negative 4, right? Because negative 16/4 is definitely below negative 3. And over here, when I plug in a negative 3, remember we said we got the same value here, negative 3, and then negative 15/4. All right, there's my graph. Ooh, I like thinking. So let's take a look. We said that when the degree of the numerator was bigger than the degree of the denominator, that we would have a slant asymptote. And how do we deal with that? Well, let's take a look at this one. Y equals x squared plus x minus 6 over x minus 1. Now, up here, I can factor x plus 3, x minus 2, and on the bottom, x minus 1. So I like this, the factored approach, for finding the x-intercepts in the vertical asymptote. Finding the y-intercept, yeah, I like this better, because all I have to do is say negative 6 over negative 1, or 6. I will, though, need to be looking at this one to figure out what my slant asymptote is. Before we get to the slant asymptote, let's find those other things. We said a y-intercept of 6, x-intercepts at negative 3 and positive 2. Vertical asymptote when the denominator is equal to 0, x equals 1. And because the degree of the top is bigger than the degree of the bottom, we know we've got a slant asymptote. So how do we find that slant asymptote? Let's kind of do some long division. No real. So what happens now? Well, what do I multiply this by to turn into this? And then I distribute and subtract. This minus this minus a minus this. And don't forget to bring this down. What do I multiply this by to turn it into that? A 2. Now, you know, in our polynomials unit, we went further and we got to this. Yeah, I'm not going to do that. As soon as I get to the point where I can say, what do I have to multiply this by to turn it into this? Oh, 2, a positive 2. I'm going to stop here. And the reason I'm going to stop here is because I have this linear function. That's my slant asymptote. That's the one I'm going to use. Slant asymptote, x plus 2. Now, I said you have to use long division. You can use synthetic here in this situation, but not always, right? Remember, we can't be synthetic if we have a Colin, if we have some sort of nonlinear factor here to deal with. So that would look like 1, 1, 1, negative 6. And remember, here I'm adding 2, 2, negative 4. I don't need the remainder. I just need this part. We were at y equals x to the second. We divided by an x, so x to the second divided by x brings us to x to the first. I can get that this way, but I can only get that this way if this thing is linear. If I've got more than one vertical asymptote, or if the degree here is 2 or bigger, then I can't use synthetic. So I'm not going to try. Okay, so what do we know? We know a bunch of x-intercepts and a y-intercept and a vertical asymptote, but that's the one I want to graph first. So y equals x plus 2. The slope is 1. The y-intercept is 2. So 0, 2, and a slope of 1. Now, I'm just eyeballing it. You could certainly plug a 1 in here and get the point 1, 3. 1, 3. And you could get negative 1, 1. But I really don't want to go there because really these are supposed to be fast graphs. So what else do I know? Well, I do know that I have an x-intercept at negative 3. Is negative 3 over here, or is negative 3 over here? I guess I do need to find the x-intercept there, which means I need to set y equal to 0, and then I get, oh, that's negative 2. So negative 3 is going to be over here. Now, didn't we have a vertical asymptote at 1? Okay. X equals 1. And we had an x-intercept at 2 over here. Good. Y-intercept at 6. Well, where's that point? That point is when x equals 1. 1 plus 2 is 3. So I know the y value here is 3. If I'm looking for a y-intercept to be 6, well, my y-intercept is going to be up here-ish. And then I have to bend to the asymptotes. And I'm going to write this one goes and I'm going to bend to the asymptotes. Isn't that interesting? It's a very different shape. I know, you're having a hard time seeing it, so let's try again. So we've got that slant asymptote, and this is 2, and this is negative 2. We've got a vertical asymptote at 1. We have our x-intercepts at negative 3 and positive 2, and our y-intercept way up here at 6. Okay. Now, I remember there's something on either side of this, and over here on the left side, I'm either going to be above the slant asymptote, or I'm going to be below the slant asymptote. Likewise, on this side, I'm either going to be below the slant asymptote or above the slant asymptote. So what do we have? Well, we have to connect these dots and bend to those asymptotes. It almost looks straight, but it isn't. And bend to the asymptotes. Okay. Are you ready to try one? Yeah, I didn't think you'd want to, but here you go. Here's one for you. Okay. Y equals x squared minus 4x minus 5 and x minus 2 on the bottom. Give it a try. We have the degree of the top is bigger than the degree of the bottom, so you know this is going to be a slant. Pause the video, graph it, come back when you're done. Hey everyone. Yeah, I'm going to get the thing that I don't want to do most done first. What do I multiply to turn into this? And I distribute squared minus 2x. Don't forget we're subtracting here, Minus 4 minus a minus 2 is going to be minus 2x minus 5. What do I multiply this by to turn it into this? A negative 2. Okay, and I'm not going to stop. I mean, I'm not interested in knowing what my remainder is. Doesn't matter. I just want to stop when I've got my slant asymptote, which is this linear thing here. Okay, so graphing. I see a vertical asymptote at 2. I've got my slant asymptote, x minus 2, negative 2, 2 on the slant asymptote. Y-intercept, 2.5. X-intercept, well, I should probably factor that. And so 5 and negative 1. So I'm going to go with negative 1. I'm going to go with positive 5. Hey, that's very reassuring. It's even the same sort of orientation and shape as the last one. Done. Sometimes we're here, sometimes we're here, and I will have to say I've never been one on the outside and one on the inside. I actually, if you want to do some experimenting and figure out if that's possible, I'll give you some extra credit for that. But I'll need to be convinced that you can have one of these and one of these, and not just these diagonally things. Okay? All right. Well, good job, you. But I'm not convinced yet. Maybe what we'll do is we'll go through the other cases to look at, and then if we have more time, we'll go back and do some more practice. But really, we should practice some more. Yeah, how about this one? We should do this x squared over x plus 1. Okay, but not right now. Wait, do this one later. Okay, right now though, I want to talk about holes. So a hole is an undefined point on the graph. And while a vertical asymptote is also an undefined point on the graph, a hole is different because we bend to an asymptote and we don't bend to holes. A hole is actually born of two kids fighting in the back seat of the car. Okay? Imagine the situation. You're driving from Tucson to Portland, Oregon, and then you and your siblings are in the back seat, and yeah, that's a long drive, and there's like, oh, he touched me. No, she took my stuff. And finally, the tired parent turns around and says neither of you is going to be happy. How does that work here? We'll take a look. Let's imagine that I've got something like 3x squared minus 12 on top, and x squared plus 5x plus 6 on the bottom. Now, when we factor this, we have 3x minus 2, x plus 2, and on the bottom, x plus 2, and x plus 3. Now, look, set the top equal to 0. I get x equals negative 2 as an x-intercept. I set the bottom factors equal to 0, and I get x equals negative 2 is a vertical asymptote. And so there are the siblings. I want to be an x-intercept. No, I want to be a vertical asymptote. No, I'm going to be an x-intercept. No, I want to be a vertical asymptote. And mom turns around and says, no, neither of you. And so you're not going to necessarily be an x-intercept because you don't exist, and you're not going to be a vertical asymptote. No one's going to be drawn to you. Instead, when we can cancel out a factor on top and bottom, that creates a hole in the graph. Yeah, exactly, a hole in the graph. So let's think about graphing this. And when I go to graph, I can use this, but I'm also going to need to be thinking about this. 3x minus 2 over x plus 3. Or if you like, 3x minus 6 over x plus 3. Degree and top and bottom are the same. So I know that y equals 3 is the horizontal asymptote. I have a vertical asymptote at x equals -3. I see my x-intercept as x equals 2, and what am I missing? A y-intercept. Okay, so a y-intercept, I cover up the x's. -6/3, my y-intercept is -2. So let's graph what we know, but look, there's a hole at -2. So keep that in mind. Hole at -2. We have a vertical asymptote at -3. We have a horizontal asymptote at y equals 3. We have a y-intercept of -2. And we have an x-intercept of +2. Great. So do. And then over here, a test point, -4. And you can use either the simplified version or the original version. -4 times 3 is -12, -6 is -18, and -4 plus 3 is -1. And so I get +18. +18 is definitely above this horizontal asymptote at 3. So my graph is going to go here. And we're going to have -4 and 18. Now, are we done? No. Remember, we said that there was a hole at x equals -2. -2 is between 0 and -3. Hole in the graph. Not a vertical asymptote, a hole. How do we get that hole? A factor on top canceled with a factor on the bottom. I want to be an x-intercept. No. I want to be a vertical asymptote. No. Neither of you get what you want. Instead, you're going to be a hole. That's where holes come from. Okay? Please don't forget to label the hole on the graph. Now, some students want to know, well, what's the y value out of the hole? I don't really want you to be labeling that because it doesn't exist. But, some people like to be able to find that out. And if you want to find the y value of the hole, you can't use the original function. That's going to give you 0/0. But you can use this one here, the simplified version, or the simplified version here. If we plug in a -2, -2 minus 2 is -4, -4 times 3 is -12, and a -2 plus 3 is 1. And so this is going to be -12. But you don't have to label the y value of the hole. I just need it in the right place. Okay, hole. What was it that makes a hole again? A hole is created when an x-intercept and a VA are the same. Or you cancel a common factor from numerator and denominator. And in that last problem, we were looking at x plus 2, x minus 2, x plus 2, x plus 3. And we canceled. That signals a hole. Okay? Are you ready? I think you should try. Come on. Y equals x plus 2, x squared minus 4. Come on, it's very gentle. You should do that one. Okay? Pause the video, come back when you're done. I set the top equal to 0. I get x equals -2 as an x-intercept. I cover up the x's, and I get 2/-4. My y-intercept is my y-intercept is -1/2. I look at the ratio of the degrees here, and I see y equals 0 is the horizontal asymptote. I set the bottom equal to 0, and I get x equals 2 and -2. And it's usually this way where people say, like, they haven't noticed yet that this x-intercept and this vertical asymptote are the same. They're just sort of going through all the stuff they know about graphing this. I might suggest that you actually do the factor, because if you do the factor, you see cancel. It's much harder for people this way to see. They don't find the hole until they start saying, okay, I got an x-intercept at -2, and a y-intercept of -1/2, and a horizontal asymptote at y equals 0, and we got vertical asymptotes at 2, and then they come over here and they do -2. And they've forgotten that an x-intercept can't exist on that place where the function is undefined. Yeah, so I would factor first. I would factor first because you're more likely to see the existence of any holes. And remember what we're graphing. We're graphing what's left over, but we're remembering to put a hole at x equals -2. Okay, so that's not there. I am going to bend to my asymptotes, and over here I'm going to plug in a test point. 3 minus 2 is 1, 1 over 1 is 1. But there's a hole. Where was the hole? The hole was at -2. We know that because we canceled those factors. Now, that is not on the x-axis, right? This kid does not win. You know, I'm not going to get to be a vertical asymptote. I'm not going to be an x-intercept. It's possible that the hole is on the x-axis, but it's very rare. Okay, so there you go, a hole. Let's try something that has both a slant asymptote and a hole. So how about y equals x to the third plus 5x squared plus 6x over x squared plus 7x plus 10. Or as my grandmother would say, hubba hubba. Now, I do think if you think there's a hole, really you should be doing the factoring first. I want to factor these things because I don't want to try and find the x-intercepts here. I'm going to start by doing GCF factoring. Like we said, we always try that one first. And now I see this nice trinomial that I can factor. And this trinomial will factor as x plus 2, x plus 3. On the bottom, this factors as x plus 2 and x plus 5. I see these canceling, so I know that there's a hole at x equals -2. I set my denominator equal to 0. I get x equals -5 for a vertical asymptote. I set the numerator equal to 0, each of these factors, and I get x-intercepts at 0 and -3. Y-intercept, well, if I plug in a 0 for all the x's, I'm left with 0 over 10 y-intercept of 0. Since the x-intercept and the y-intercept are both 0, it means I'm passing through the origin. And finally, what about my horizontal asymptote? Well, look, this degree is bigger than this degree. So I'm going to have to divide this into this, or I could take x squared plus 3x and divide by x plus 5. I could also do it over here. Which would you prefer? I kind of want to do that, but I bet you want me to do that one because you're not going to do this, are you? So much easier. Okay, so we've got x squared plus 7x plus 10 over x to the third plus 5x squared plus 6x. What do I multiply this by to turn it into this? X to the third plus 7x squared plus 10x, and I subtract -2x squared minus 4x. What do I multiply that by to turn it into that? -2, and then stop. Y equals x minus 2. There's my slant asymptote. Okay. So let's graph what we know. -2, 2. That's this piece. Vertical asymptote at -5. X equals -5. X-intercepts at -3 and at 0. Well, if this is -5, then -3 and 0. Okay, and we'll come back to the hole in a moment. So remember, I have to connect these points, and I have to bend to these asymptotes. What's going to happen here is I'm going to look something like that. Now, what about on the other side of this vertical asymptote at -5? Is it this thing, or is it down here, this thing in between? So if I plug in a -6, and I'm definitely plugging that -6 into this. -6 plus 3 is -3, negative times negative is positive 18, -6 plus 5 is -1. So I'm getting -18. Is that above the slant asymptote or below the slant asymptote? Well, if I plug that -5 into the slant asymptote equation, I get -5 minus 2 or -7. So here at -6, the y value would be -6 minus 2 is -8. But we just got -18. -18 is way lower than -8. So my graph is going to look like that. Okay? Okay. Wow, there's a lot going on here. Yeah, there is. And on tests, people don't say, find the holes. Is there a slant asymptote? You're supposed to be looking for those things. All right, will you do this one? Y equals 3x squared plus 4x over 2x. Hi, welcome back. So I factored the top, and I got x, 3x plus 4, and on the bottom, 2 and x. Look, they cancel. So I know there's a hole. Did I draw the hole in the last one? Borg. All right, where's the hole? We were doing that one, and we said x plus 2, x plus 3 over x plus 2, x minus 5, no, plus 5. So we went like this, 2, -2. We had slant asymptote, we had vertical asymptote, -5. We have x-intercepts at -3 and 0. We did this, we tested a point, and we did this, and then I walked away before labeling the hole. Where was the hole? The hole is at -2. We have a hole at -2. This is -3. This is 0. My hole has to be here at -2. Yeah, it's so tight there. I don't want to forget the information. -5, -3 and 0, x minus 2, and a hole at -2. So give ourselves a little more space and see if we can get this looking a little more like we'd like it. So I'm going here, and I'm going here with -5. This is -2, this is 2. We set it -3 and it's 0. Oops, too far. -3. And at -2, there's a hole. And then we have this piece down here, and we labeled -6, -18. Okay, there we go. I can see that hole now. Draw bigger. Use just a piece of paper. Make it really big. All right, so that's what we're looking at now. We're looking at the level of complexity that says hole. Hole exists when the factors on top and bottom cancel. And we've also got slant asymptotes to consider now. Okay? So will you try this problem, please? Y equals x squared plus x minus 6 over x minus 1. Give that one a try. Hey, welcome back. Um, we know when we see these things that we should factor them. Oh, look. No canceling on top and bottom. So there's no hole. There's a vertical asymptote. There are two x-intercepts. The y-intercept. And what else do we need? Horizontal asymptote? No, because the degree here is bigger than the degree here. So we're going to have slant asymptote. So we need to do some division. X squared plus x minus 6. It's going to be x squared minus x. I'm subtracting 1 minus a minus 1 is 2. Really have to have that one down. I know. Still making mistakes with that. That's why we spend so much time in middle school doing just this, so that you would not come up with 0 there. Okay, so what do I multiply this by to make that a 2? There's my slant asymptote. So I've got a vertical asymptote at 1. I've got a slant asymptote called y equals x plus 2. I have an x-intercept at 2. That's on the other side of 1. I have an x-intercept at negative 3. That's over here. And a y-intercept of 6, which is going to be up here. So I'm going to bend to my asymptotes and bend to my asymptotes. Alrighty? Alrighty. And no holes to worry about. Yay, no holes. How about this one? Y equals x squared minus 1 and x plus 1. Let's give that one a try. Factor x plus 1, x minus 1, x plus 1, whole at x equals negative 1. This is the thing that I'm graphing. I'm graphing what's left over. That's just a line. It's this line. I'm graphing this line that has a y-intercept of negative 1 and an x-intercept if I set this equal to 0 and add 1 to both sides, x equals 1. I graph what's left over. This does not look like a rational function. Well, it is. And there's a hole at negative 1. So at negative 1, I have a hole. There's my graph. No, really, this is it. This is the whole thing. I know it's weird when that's like linear. We expect it to be, that other curvy, bendy thing. No, I know. You're saying, but Mr. Kukla, what about the slant asymptote? Isn't the degree here bigger than the degree there? It sure is. So let's do some division. X plus 1, x squared plus, don't forget the 0 placeholder, minus 1. What do I multiply that by to turn it into that? X. Get x squared plus x, and I subtract. And now I have negative x minus 1. What do I multiply that by to turn it into that? A negative 1. But Mr. Kukla, the slant asymptote and what's left over, they're the same. Yeah, I know. Isn't it cool? Look. The graph sits on top of the slant asymptote. I know you didn't know you could do that. But guess what? Here we see we have to do that. What's left over that I'm supposed to graph? And the slant asymptote, same. Only difference in what I'm graphing is that I have a solid line on top of that asymptote with a hole at -1. Okay. Now, if we flipped these things so that we had x plus 1 on top and x squared minus 1 on the bottom, I'm still going to have this canceling, but now I have this x minus 1 down here on the bottom. So I'm going to be graphing this and putting a hole at -1. So this one has a vertical asymptote over here at 1, and a y-intercept of -1, a horizontal asymptote, because the degree here is smaller than the degree here, at y equals 0. And so I end up with this. If I plug in a test point like 2, 2 minus 1 is 1, 1 over 1 is 1, 1 is bigger than 0. So 2, 1 here, and bend. Am I done? No. Don't forget the hole. There's a hole at x equals -1. Okay, don't lose those holes. Don't lose those holes. Speaking of which, how do you know if there's a hole in the graph? And the answer? Factor on top cancels factor on the bottom. Okay, next, how do you know if there's a slant asymptote? Ooh, how do you know? So, how do you know if there's a slant asymptote? And the answer is the degree of the top is bigger than the degree of the bottom. Okay. And I guess we want to add as questions, when will the graph sit on top of the slant asymptote? Like we saw in that last one. And that happens when what's left over after canceling equals the slant asymptote equation. And I'll say parenthetically, if what's left over after canceling is linear, y equals x minus 2, y equals x plus 3, linear equation, that's when that's going to happen. Yeah, nice. Okay. I think we're going to stop here. And but really, maybe you should practice some more. And if you need help finding practice problems, how about doing the homework questions or the synchronous Zoom problems? All right. Have a great day, everyone. Reach out and let me know if you have any questions. Take care.